Hello everybody, this is Praveen and my partner Akshay, and we are going to explain the first lab for E542 which we are taking under Professor Young Cho. So this is basically a lab for the introduction of socket programming, and for that we'll begin with building a simple client server model. So I'm just going to before that, I'm just gonna explain what we are doing here. The machine you see on the left is the server machine, and the machine which you see on the right is the client machine. So I'll be basically handling the server machine, and Akshay would be basically handling the client machine. So for that, I've already written the code for the server program, and I'm just gonna run that program now. So I'm just running this program over a port number 25,000, and the client, which is Akshay, is also going to use the same port number to connect to the server. And since this is a simple client server program, here what happens is once the client sends a message to the server, both the client and the server terminate their program. And I'm going to say why this is not a good method, but let's look into the first program now. So I'm just going to initiate and run the server program now. So I've activated the server, and let's see if Akshay is able to send me a message.
So moving to the client side, let's first compile the program, and I'm gonna use client.c code which we have written. Let's run it on the IP address given by Praveen and specify the port number, which is 25,000. Okay, so it's asking for a message, and let's just give a simple one. Simple server client program.
Yeah, as you can see on the left, I'm now received the message. So this is a simple client server program. As we spoke early, both the client and the server terminated their connections once the message was transferred, but this is not actually a good idea if you go into the real world, because you don't want the server to terminate, because the server generally communicates with multiple clients in general. So we have made an enhancement to the code, and there are a couple of enhancements we have made. The first enhancement is basically to make sure that the client learns indefinitely, and the second one is to remove the zombie process. So we are just going to look into the first enhancement, which is in which the server would be running indefinitely. So I'm already written the code for that. I'm just going to run the program. Yeah, I guess the port is already in use. We can use some other port. Yeah, this one is working. Yeah, and Akshay is now going to send a message for that.
So let me run the client, and since the port has changed now, I'll make the changes, and yeah, so I'll ask for the message again, and I'll just say this is with forking, and let me send one more message. This is forking message 2.
So as you can see, there were a couple of messages sent, and the server still kept on running. So if I could give you an overview of what the code actually did in the background, I'm just going to quickly run you over that. So as you can see here, what we have actually done is we have introduced forking. So forking is basically where a parent process is going to create multiple child processes. So once a child process is created, it will get a PID of 0. It will close the previous connection which it was established, because now the client could have two connections. So it will close the initial connection, and then it will basically accept the connection from the client and do that and print that on the screen, and it will exit. But the problem with this enhancement what we have made is, I can quickly show that. I'll probably open a different tab for this. Yeah, so I'll run the ps minus a command, which will show me all the running processes. So as you can see here, this is the process which is running my initial program, server program, and this two are the zombie processes which are created. So we have to get rid of this thing. So for that we have made another enhancement. For the enhancement what we have made for that is, just gonna quickly show you the modification what we have done for that. So right, so for that we have introduced the concept of sig catcher function. So what does this function actually do is this will wait for all the child processes to be dead, and once the child process, here the parent is actually waiting for the child process to die, and once the child process dies, the parent is gonna to automatically clear everything, the zombie processes. And zombie processes are nothing but the processes which remain, because in future we may need the necessity to make sure that the client connects to that again. So but it can hog a lot of memory. For that reason we generally prefer, and it's a good programming practice to clear all the uh, zombie processes. Now I'm just going to terminate the initial one. I've also written the code for the second enhancement, and I'm going to run that over. Let's see if this port is available. Yes, it is available, and my server is active now. And let's see if Akshay is able to send me message now.
So with the zombie process elimination code modification, let's run the client side. The ports are fine, and it will ask for the message again. Let's say this is without zombie.
One thing I can quickly show you is I can see all the active processes again, and as you can see I don't have any more zombie process. So we only have a process created. Let's see if Akshay sends me a establishes the connections and not send me a message. So let me see what is the state of my processes now. So now right now I have two processes, but Akshay has not yet sent me a message, so the connection is still required. So once he sends me a message, I guess that should go away. Yeah, now I've received the message, and let's see now. Yeah, so as you can see, they are only my server process and the other background process which is running now. So we have got rid of the zombie processes now. And whatever we did prior to this, all the communication was done over TCP. We also can do it over UDP, but it has its challenges because UDP over some congestion traffic can drop your packets. For that, we will terminate this. I've already written the code for that. I'm just going to run the UDP code. Right, so this is going to run my UDP code.
On the client side, I've compiled the just a second. Okay, so there's some mistake in the spelling. Sorry about that. So now if we compile it and then run it, giving the same IP address and the port number, it will again ask for a message, and let's say this is UDP first message.
Yeah, as you can see, I've already received the message from Akshay and the connection has been established. So I'm just gonna summarize what we did in this lab. The first thing which we did was to build a simple client server program, and we looked into what were the challenges with that it didn't, the server was not running indefinitely, and we had the problem with zombie. So we went on to encounter those problem, and at the last we also tried sending the packet over UDP rather than TCP. Thank you for being with us. Bye for now.